So in this question, we are given a set R in which we are having mappings. One is mapped to 3, 4 is mapped to 2. So remember, this is a representation of mapping. The question will not say that X is mapped to Y, not directly at least. So this is a relation on the set A, right? So R is a relation. So the relation word itself says that whatever inside the bracket is, they are mapped to each other. That means, and it is a relation on this set. So this is made from these numbers inside the set. So the relation is, now we are given different properties in the option. Is a function, is reflexive, it's not symmetric or transitive, right? So let us try to make sense of this relation by plotting it visually. So it's from A to A, right? So we have mapped the different numbers which are given on a domain and to its range. So 1 is mapped to 3, 2 is mapped to 3 as well as 4, which we can see here, and 3 is mapped to 1 and 4 is mapped to 2, right? All right. So now we'll see the definition of a function. So a relation is a function if each element of domain maps to exactly one element. So that's the definition of a relation when it is a function. So 1 must be mapping to a single number. So is there any number on the domain which is being mapped to two things? Right. So we can see 2 is mapped to both 3 and 4. That means it is not a function, right? It is not a function. But the option says that a function, that means this is rejected. All right. Now it is asking that to check for reflexive. All right. For reflexivity of a function, what is the condition? That when if a comma a is belonging to R for all values of a belonging to the set A, then we need pairs of 1 comma 1, 2 comma 2, 3 comma 3 and 4 comma 4. But is there any pair like that in our given relation? No, everything is different, right? So they are absent. That means it is not reflexive. Not reflexive, right? All right. So now what is the third part? Third is not symmetric. So let's see if it is symmetric or not. Remember, it is not saying symmetric. It is saying not. So wherever there is a not or no, we have to take a close observation on that. All right. So let's check for the symmetry. If what does the rule of symmetry says that if a comma b belongs to R, then b comma a also has to belong to R for all a b which are belonging from set A. So let's check each of the pair which is given to us in the given relation. So 1 comma 3, if it is there, then 3 comma 1 must be there, which is there. 4 comma 2 is there, then 2 comma 4 must be there, it is there. But 2 comma 3 is there and 3 comma 2 is not there. See, 2 comma 3 is there, but 3 comma 2, do you find anywhere? No, we cannot find it, right? That means that it is not symmetric, right? It is a very basic symmetry. It is very easy to find all these things. All right. So the fourth option is asking to check for the transitivity. Transitivity. So for transitivity, the rule is that if a comma b belongs to relation R and b comma c also belongs to the same relation, then a comma c must also belong to that. So let's check. Let's take one pair and check if it is working or not. So we took 1 comma 3, which is obviously belonging to R, and 3 comma 1 also belonging to R. But is 1 comma 1 belonging to R? No, it is not there. And we can find many such pairs in the same relation which are not working for this transitivity rule. That means R is not transitive, but it is asking for transitive. So this option is also wrong. But we proved earlier that it is not symmetric, and it is option is also saying the same. So that means C option is the correct option.